Yes, good morning to you all, friends. I hope you all are doing good. How is your preparations going on? Yes, how are you? I hope you all are doing good. Welcome to the session once again. Today we are going to conduct the seventh session, okay? We are going to conduct the seventh session. We are going to conduct the seventh session of this particular climatology. Clear? Now, if you before I start the session, let me tell you one thing. In the middle of discussion, if you are not able to follow any points, you can always interrupt me at any time. Okay? You can interrupt me by signaling me in the live chat box below. Okay? Because it is the only option through which we can communicate each other. Okay? If it was in Unacademy platform, we have many different tools like raise hand, so on and so forth. I also have my plus course in Unacademy platform where we get ample amount of time. The tool is much more efficient. Okay, so you can always come and join me there also. Okay, but anyway, here in the YouTube session, you can just signal me by interrupting me at any time in the live chat box below. Clear? In total, I am planning to take 9 sessions. Today is the 7th session. So, leaving today's session, we have another 2 more sessions. Okay, there I will try to cover at least some important topic regarding the climatology as far as your UPSC exam is concerned. Okay, we have already taken up many important topics. Today also we will go and try to see some important topics. But before we go into the session, let me give you some important information from the Unacademy platform. You see here, you lose nothing by attending such a UPSC Mega Compact which happens every Sunday. So now also this upcoming Sunday, that is 19th of December, every Sunday at 11 a.m. you will be asked 56 questions to be solved in 60 minutes. Now one important thing is, you see here, UPSC exam, you don't have any kind of pass mark. It is a competitive exam. Therefore, by attending such a mega compact, you will know at what level of preparation you are. Self-assessment, that is very, very important. Okay? Now, number 2, nothing like practicing for your MCQ through this kind of a mega compact. Okay? And you just have to sacrifice or devote 1 hour, 60 minutes. You lose nothing, you only gain. Gain in a sense, you will get scholarship. Along with that, you will get such a important gift also. Okay, apart from that, scholarship from a pool of somewhere around 6+ crores. For this, you can use my code, that is SUNEP10. Okay. UPSC annual price hike in the Unacademy is going to affect very soon. One already happened on 9th, another only 1 or 2 days on 16th December. After that, a mega price hike is expected. That's why if you haven't subscribed or enrolled, kindly do so before this mega price hike happens, so that you enjoy the benefit of the discount. Such as for a course like Plus Combo, you can use my enroll code SUNEP10 if at all you require. Okay. Also, you have a Plus GS course. Again, the same structure. One price hike is expected on 16th, and after that, a massive price hike will be there. So before, if you haven't subscribed, kindly do so. Okay. It's only 2 days to go for 16th, and after that, again, a major price hike will be there. Keeping in mind your prelims, which is almost 6 months from now, in the month of June 2022, new batches have been started. Okay, one started on 10th of December and one starts on 15th, that is tomorrow. Mission batch for 2022, okay, batch for 2022 and 2023 as well will be beginning on 15th of December. If you haven't subscribed, kindly do so. If you at all require a code then you can use my code, that is SUNEP 10. Clear? Free test series. Apart from the UPSC Mega Compact, which happens every Sunday at 11 a.m., you have 3 different types of test series also free, which is completely free. One is Mrunal's Monday. You will have 20 MCQ, 20 minutes. Language is both in English as well as in Hindi. Every Monday at 8 p.m. Clear? Another one is the T20 Current Affairs, Daily Current Affairs. Deals with the current issues. 15 MCQ, 15 minute, both in English, Hindi, every Monday to Friday, 7:30 p.m. Abhiyan, that is the static part, again, both in English and Hindi, Monday to Friday, 10 a.m. You can use my enroll code, that is SUNEP 10. Clear? Chalo, let us go ahead with our topic of discussion of today. Okay. Today we will be seeing one very, very important concept of atmospheric stability and instability. Atmospheric stability and instability is whether there is a vertical circulation of air or not. Even if there is a vertical circulation, whether the vertical circulation is upwards or downwards. Now, depending on this vertical, see, as far as our climatology is concerned, we have height also. So not only the wind or the climatic phenomena which is observed on the ground surface that we study, but at the same time we study the vertical circulation. Vertical circulation can be of 2 forms. One is upward motion, downward motion, or no motion at all. Now, depending on the vertical motion, whether it is upward or downwards or stable or no motion at all, different climatic and weather phenomena occurs. Say for example, for the cloud formation, a vertical upward motion of the air is important. If there is a vertical downward movement of the air circulation, it results in no cloud formation, clear sky. But when there is an upward motion, then a cloud formation is there, which means depending on the vertical circulation of the air, okay, the certain weather and climatic phenomena results. Now, you see here, in order to understand vertical upward or downward motion or no motion at all, we need to know certain important terms. They are normal or environmental lapse rate, adiabatic lapse rate. Under adiabatic lapse rate, there is a dry adiabatic lapse rate and wet adiabatic lapse rate. Let us see one by one what all this means. You see here, say for example, in your own surrounding, okay, in our own surrounding, the air that is, or the atmosphere which surrounds us, if we go up, the temperature of our surrounding will decrease. Why it will decrease? We have already seen under our structure of the atmosphere, the moment I move away from the surface of the earth, since I am moving away from the source, heat source, because heating of the atmosphere, although heating of the atmosphere happens because of the sun insolation, the heating of the earth atmosphere happens from below because of the long re-radiated wave from the ground surface. Clear? And atmosphere consists of different water vapor, greenhouse gases like CO2 captures the long wave re-radiated, re-reflected back to the earth's surface. That is how the temperature increases. Therefore, during our structuring of the atmosphere, we have seen the moment we move away from the surface of the earth above, the temperature will reduce. That's why in the troposphere, we have already seen in troposphere temperature reduces like this. Clear? The temperature of the surrounding which get reduced like this is known as normal or a environmental lapse rate. Now, the term is very, very important, so kindly pay attention. Normal lapse rate, environmental lapse rate means the decrease in the surrounding air temperature as we go upward. Now, in equatorial region, the normal or environmental lapse rate will be different. Why? Because the sun insolation is different. In the polar region, it will be different. Okay, now, depending on different latitude, normal or environmental lapse rate will be different. Do you agree? On the other hand, normal or environmental lapse rate will also change as per the season. During summer season, during winter season, it will change, which means normal or environmental lapse rate, which means the temperature reduction vertically when I go from the surface of the earth towards upward is known as normal or environmental lapse rate. Clear? Grace, Terry, good morning and welcome to the session. Clear? So, normal or environmental lapse rate is the moment I go up, the reduction in the temperature of the surrounding air or surrounding atmosphere is known as environmental or normal lapse rate. It changes as per the location. In equatorial region, it will be different. In tropical region, it will be different. In polar region, it will be different. In temperate region, it will be different. Also, depending on the season, whether it is summer, winter, it will be different. But all in all, we take one approximate value. That approximate value is 6.5 degrees centigrade per every kilometer. Normal environmental lapse rate. Remember, it changes with climate, it changes with different latitude, different location, it changes with different season, whether it is summer or winter. But on average, we take one average value, that is 6.5 degrees centigrade per every kilometer height. Okay? Keep that in mind. Now, there is one heating and cooling process which is known as adiabatic heating and cooling. What is this particular adiabatic heating and cooling? First, let us see that. Okay. Kindly follow the pointer. Very, very important. You see here. On the surface of the earth. Okay. Consider this is the surface of the earth. Now, here in this normal or environmental lapse rate, I am taking the entire atmosphere and considering it, when I go up from the ground surface, the temperature reduces of the atmosphere surrounding air. When I am talking about adiabatic process, I am considering a parcel of air. Remember that. I am considering a parcel of air. If this parcel of air heats up, okay, if you heat this parcel of air, it will become light. When it will become light, it will move up. Now, when it moves up, you see here, atmosphere is having highest density at the surface. The moment you go up, the density of the atmosphere is less. Therefore, when this parcel of air is heated, it becomes light, it will go up. The moment it goes up, since it will encounter a less dense environment or surrounding, this parcel of air will expand. Clear? Now, so this parcel of air will expand like this. Again, if it goes up higher, again it will expand more. Clear? Now you see here. Adiabatic process means there is no exchange of heat away from this parcel of air to the outside, nor from the outside this parcel of air is taking any heat inside. It is completely isolated unit. There is no transfer of heat from the parcel of air towards the outside, nor any heat it is taking from outside towards the parcel of air. When there is no heat transfer which is taking place, now you see here, when this particular parcel of air from the surface goes up, it expands because it encounters less dense environment. Now, for expansion of this, it requires some energy. Okay, for any work, it requires some energy. Now, this parcel of air, when it expands like this, it requires certain energy. But you see here, energy in the form of heat is neither transferred from inside of the parcel to outside, nor it is taken from outside towards the parcel of air. So, the energy required for expansion is taken from within the air parcel itself. Therefore, this temperature get reduced. Why? Because I am taking the heat energy for expansion. Means the parcel of air is utilizing its own energy. Therefore, when I use the energy for expansion, then since there is no transfer of heat from inside to outside or outside to inside this parcel, the temperature of this parcel of air will reduce. If you go up higher, more expansion, which means the temperature has to come down. But remember here, temperature is reducing, but the content of heat remains the same. That is important. You see here, in adiabatic process, the content of heat in the parcel of that air remains the same. But since I am taking that energy for expansion, the temperature has to reduce. Okay, that is the basic principle of adiabatic cooling. In any kind of adiabatic process, there is no transfer of heat. And since a parcel of air, when it moves up, it encounters a less dense environment or surrounding, therefore it expands. The energy for this expansion is taken from the parcel itself, therefore it has to reduce its temperature. That's why when parcel of air, when moving up, cools like this, temperature reduces like this, cools like this, it is known as adiabatic cooling. And this adiabatic cooling is known as triadiabatic cooling when this parcel of air is not fully saturated. Okay. Now, this particular triadiabatic cooling is 10 degrees centigrade for every kilometer. So, this parcel of air, when it goes up, for every 10 degrees centigrade, for every 1 kilometer height, reduction of temperature is 10 degrees centigrade. Now, this 10 degrees centigrade is fixed. It does not change with the climate. It does not change with the location. It remains fixed in the entire world, whether it is polar, whether it is a equatorial region, whether it is a tropical region. Whether it is summer, whether it is winter, it remains the same. That is known as triadiabatic lapse rate. You can contrast that with this normal and environmental lapse rate, which I have just explained to you. Environmental and normal lapse rate is the air of the surrounding. Triadiabatic lapse rate is parcel of air. Remember, normal environmental lapse rate is not fixed. It changes with location, it changes with the season. Approximately, we take it as 6.5 degrees centigrade per every kilometer. But triadiabatic lapse rate remains fixed. It does not change with season nor with the location. It is 10 degrees centigrade for every 1 kilometer. Now, the upward moving air, which is cooling at adiabatic rate, if it becomes saturated, then it is known as wet adiabatic lapse rate. And this saturated air, which goes up and cools down, it will cool down at within 5 to 9 degrees centigrade for every kilometer. Clear? I hope that is clear. This is known as adiabatic cooling. Adiabatic cooling is either a triadiabatic cooling or wet adiabatic cooling. Clear? Any doubt regarding the point that we have discussed so far? Very important concept, okay? Now you see here. Another important point is, you see here. Now, this is when there is a vertical motion upward. Now you see, consider just the opposite. If a parcel of air is coming down, okay? If a parcel of air is coming down, now, when this parcel of air is coming down, it will encounter a more dense atmosphere, okay? Density of air is maximum near the surface. The moment I go up, the density reduces. When a parcel of air is coming down, okay, it is encountering more dense atmosphere or surrounding. Therefore, this parcel of air will be compressed, which means it will become smaller, the space. The moment again it comes towards the surface, the volume becomes less because dense atmosphere it encounters. If this is an adiabatic process, since there is no exchange of heat from parcel of air outside or from outside towards the parcel of air, see this contraction, because of this contraction, the temperature of this parcel of air will increase. And such an increase is known as adiabatic heating. Clear? Adiabatic heating. Therefore, whenever air goes up, parcel of air goes up, it cools down. Whenever it comes down, it heats up because of like this. Clear? Now, we all know one important term, that is latent heat. Now, because of such kind of cooling and heating which is taking place, especially the cooling which is taking place like this, a parcel of air, when it goes up, it cools down. Okay, now in the process, this kind of a vertical circulation, especially the upward vertical circulation, is responsible for transferring of heat in different regions of the Earth atmosphere. You see how the transferring is taking place. What is this latent heat? Latent heat is a heat which is transferred or which is stored in the body when it changes from one state to the other. So the water, when it changes from water to water vapor state, this latent heat is stored here. Now this latent heat will store there unless and until there is a change of the state. Therefore, whenever this parcel of air goes up, cools down continuously, a condensation or a dew point will come. During this condensation and dew point, the water vapor will again turn into water droplet. So when there is a change in the state, this latent heat is released in the upper atmosphere. Now you see, from the ground surface, the heat is taken in the form of latent heat, goes up and released in the upper atmosphere. And it is the transfer of heat which is taking place in that manner. Clear? Now you come here. Now we know what is environmental lapse rate, what is adiabatic process, what is tri-adiabatic lapse rate, what is wet adiabatic lapse rate. Clear? Now with that particular understanding or the knowledge, let us see whether there is a stability, instability of the atmosphere, and in what type of a situation an atmosphere will be stable, in what type of a conditions or a situation that the atmosphere will be unstable or unstable. Clear? Now you kindly see the diagram which is in front of you. Kindly look at this two particular graph which is in front of you. There are two lines. Let me tell you, kindly follow the pointer. This is a temperature axis, okay, temperature axis. This is altitude, that is the height, okay, the height. This is a ground surface, this is a ground surface, this is the height, okay. Now you kindly observe, there are two lines. One is a white line, one is a black dotted line. And remember, it is a graph representing the temperature characteristics only, okay, temperature characteristics of a parcel of air and the surrounding, okay. Remember that this particular graph or diagram is a representation of a temperature characteristics of a parcel of air and its relationship with the atmosphere, okay, atmospheric temperature condition. Now I will take one parcel of air. This parcel of air temperature characteristics is, we have just seen now, the tri-adiabatic lapse rate. When it heats up and it goes up, okay, when this parcel of air is heated, it will go up. But the moment it goes up, we just know the adiabatic, tri-adiabatic cooling. It will cool down. So this is a temperature characteristics represented by this particular white line here. Okay, now this is cooling down at what rate? 10 degrees centigrade per every kilometer. Okay, 10 degrees centigrade per every kilometer. This is a fix. Now, this particular black line represents normal lapse rate or environmental lapse rate. We know what is normal lapse rate, environmental lapse rate. I have just explained to you. It is the temperature characteristics of the atmosphere or the surrounding. It is not fixed, but on average we take it as 6.5 degrees centigrade per every kilometer. Now, if the situation of atmosphere is like this, you see here, this particular parcel of air which is cooling at this rate, now at this particular height, say for example at this particular height, altitude, I compare this parcel of air with the surrounding temperature. This white line represents the triadiabatic lapse rate of a parcel of air. Now at this particular altitude, height, I consider this parcel of air with the surrounding. Now this is a temperature axis. Now which one is cooling at a much faster rate? It is the parcel of air which is cooling at the triadiabatic lapse rate, which is much faster. Why? Because you see here, this black dotted line, which is the normal or environmental lapse rate, is cooling at a much slower rate. Therefore, at this particular height, which one will be more cooler? This parcel of air or the surrounding? This is a temperature characteristics of surrounding atmosphere. This is a temperature characteristics of a parcel of air. Which one? You tell me. Which one will be much having a lower temperature? This parcel of air will be having a lower temperature. Lower temperature compared to the atmosphere means when the temperature is low, it is heavier. The air is heavier. Therefore, this particular vertical movement will be there or not for this parcel of air? No, there won't be any vertical motion. Why? Because the atmosphere is much warm as compared to the parcel of air which is very cold. Cold means heavier. That's why in a surrounding which is so light, how a very heavy parcel of air, because it is cooler in temperature, how can this parcel of air can go up? Therefore, you consider at this height also, you see here, at this height also, this parcel of air temperature is much cooler, means heavier. The air is much heavier compared to its surrounding. This is a temperature characteristics of environmental lapse rate or normal lapse rate. That is the temperature of the surrounding air. So it is much lighter, means much warmer, means lighter. So this parcel of air which is heavier, cooler, will not go up. Therefore, if the temperature characteristics of parcel of air cooling at triadiabatic lapse rate and the surrounding atmosphere is of this nature, there will be stability in the atmosphere. Stability means there won't be any kind of vertical motion. Why? Because you see here, there is no question of any upward motion, upward movement of this parcel of air. Why? Because it is cooling at a much faster rate as compared to the surrounding area. So in such a situation, we call it as a stable atmosphere. Stable atmosphere means there won't be any kind of vertical motion, upward motion. When there is no vertical upward motion, the sky will be very clear. There won't be any cloud formation. There won't be any rainfall also. That is the significance. Clear? Now, you come to this particular diagram. You see here, this is a B, this is B. This is white line corresponds to triadiabatic lapse rate, which is fixed. That is 10 degrees centigrade for every kilometer. That's why it remains the same. But this black dotted line is a normal lapse rate or environmental lapse rate, which we have already seen that it is not fixed. On average, we take it as 6.5 degrees centigrade for every kilometer, but this normal lapse rate changes. It is not fixed. It changes depending on the season. It changes depending on the location, that is equatorial location, polar location, so on and so forth. Therefore, this is fixed, but I can shift this one. Suppose if I bring this temperature characteristics of the atmosphere representing by this environmental lapse rate or normal lapse rate to this location here like this. You see here like this. Suppose if I bring here like this. Now you see. We will do the same exercise. That is the parcel of air. This is a temperature axis. This is height. Now you see. I come to this particular location. This is fixed. 10 degrees centigrade for every kilometer. Now, here in this situation or in this particular conditions, the environment is cooling at a faster rate. You see here, this is temperature axis. Environment is cooling at a much slower rate here. But here it is cooling at a much faster rate. Therefore, at this particular height, you see, what is the characteristics? Now, you see here, which this parcel of air temperature will be cooler or this surrounding temperature. the surrounding temperature will be much cooler as compared to the parcel of air. Therefore, since it is much warmer as compared to the surrounding, it is lighter, the parcel of air, as compared to the surrounding. So this parcel of air is light, it will go up. Now you come to this location also. You consider this parcel of air, the temperature characteristics with the surrounding. It is cooling at a faster rate, so it is having a lower temperature, means heavier. The parcel of air is warmer, means lighter, so it will go up. So in such a scenario, the upward vertical motion will be there. Such kind of situation is known as instability of the atmosphere. Whenever there is instability of the atmosphere, vertical upward motion will be there, cloud formation will be there, rainfall will come down. So that is the basic understanding of why in certain places clouds are formed, why in certain places clouds are not formed, why in certain places upward motion is there, why in certain places there is no upward motion. समझ में आया? That is known as stability and instability of the atmosphere, which is very, very important. Now, there are different type of stability and instability. Okay, mechanical instability, absolute instability, absolute stability. You kindly go and see. If you want more idea regarding this, as I told you, in YouTube, because of paucity of time, I won't be able to explain everything in detail. But under our Unacademy platform, I have a plus course. You can always come and join me there. There we discuss everything in detail. Clear? Now, let us go and see the cloud formation then. We have been talking, when there is a vertical upward motion, there is a cloud formation. Therefore, let us see. Cloud is again very, very interesting topic. Now, all the cloud does not give rain. Okay, remember this. All the clouds do not necessarily will give rainfall. But for the rainfall, you need cloud. If there is no cloud, no rainfall. But all the clouds not necessarily give rainfall also. Okay, that you need to understand. What is clouds? Clouds are nothing but the visible aggregation of minute water droplets or eye particle. Just now we have seen a parcel of air, when it goes up, it cools down. When it cools down, it will turn into water droplets or it may turn into eye particle. Collection or aggregation of all of this minute water droplets around a nucleus coming together to form a cloud. Clear? Now, the entire cloud that you will observe in the sky, okay, in the sky, can be broadly classified into three. Okay, you see here, cloud, if you follow a very systematic approach, okay, which we are going to do, it is very, very easy and it's also very, very interesting and very, very educative. At the same time, it has got lots of relevance, practical relevance also. Clear? Now you see here. If you follow this very well, from now on, if you go out and look at to the sky, the clouds that you will see, it will have a new meaning itself and it will be very interesting to watch the sky. Okay, anyways, the entire cloud that we have in the sky can be broadly classified into three. One is the upper level cloud or the high level cloud, middle level cloud and the low level cloud. So the broad classification of the cloud can be divided into three: high level, middle level and low level. Now, among this, there are some exceptions like the cumulonimbus cloud, which extend from a very from a height very near to the ground surface to a very large extent. These are some special clouds which we will study later. But first, high level, middle level, low level. You kindly look at the cloud here, which is in front of you. Kindly observe. Cirrocumulus, it is a high level cloud. Cirrus cloud, high level cloud. Altocumulus, altostratus, they are middle level cloud. Stratocumulus, stratus and cumulus, they are low level cloud. We will see one by one and what is their important characteristics. The first is, let us see the high level cloud. A cloud which is formed at around 5 to 13 kilometers above the Earth's surface, it is known as a high level cloud. Under this high level cloud, The first category is cirrus cloud. Cirrus. Now, kindly see the picture which is there in your screen. It is a high level cloud. Now, what do you observe? It is a detached cloud. Okay, it is white patches, hair-like appearance. You can just observe by yourself in the picture. It is composed of eye crystal. Halo effect is present. What is halo effect? I will discuss later. It gives a brilliant colors at especially sunset and sunrise. And this particular cirrus cloud will not give rise to rainfall. You see, I just told you for rainfall you need cloud, but all the clouds will not give rainfall. Cirrus is one such type of a high cloud which will not give you rainfall. It looks like a hair-like appearance. It is composed of eye crystal. It produces halo effect also. Clear? This is known as a cirrus cloud. Clear? Cirrocumulus, another type of high level cloud. It is very thin, white patches regularly arranged mackerel sky. You see here. You kindly see the picture in front of you. Okay. You just have to watch the figure and try to correlate a special pattern that it creates. It is a thin cloud, white patches again, regularly arranged. See, it is regularly arranged. This is also a high level. The cirrus was also high level. But the cirrus was hair-like appearance. Here you have a regular arranged mackerel sky you will find. This is also high level cloud. The third type of cloud, which is again a high level cloud, it is known as cirro-stratus cloud. This cirro-stratus cloud is transparent. It is also a hair-like appearance. Halo phenomena can be observed. Halo phenomena is nothing but an optical phenomena produced by light, typically from the sun or moon, interacting with the eye crystal suspended in the atmosphere. Because of the halo effect, you will find like this. You know, this is a halo effect you see here. Optical phenomena produced by light, typically from the sun and the moon, interacting with the eye crystal which is here in the atmosphere, suspended in the atmosphere. You see here. This is nothing but the halo effect. This type of a cirrus cloud here, it gives rise to halo effect. It is also an eye crystal. Okay, sun is obscured so that the object on the ground do not cast a shadow, because it is the sun insolation is obscured by this particular cloud. It is a transparent cloud, milky appearance of the sky, like this you will find. This is known as cirro-stratus cloud. Clear? Then comes the middle level cloud. The cloud formation between 2 to 7 km above the Earth's surface is known as altocumulus. Altocumulus, kindly see the picture in front of you. This is altocumulus. What do you observe here? It is either white or gray, no halo. Halo effect we have just mentioned to you. In this type of a cloud, there won't be any kind of a halo phenomena. Okay. Dark shading on their undersurface. On the lower side of the cloud, there will be a dark shading. Complete absence of large dome or a ship. Large dome is not there. Large dome, in a sense, the cloud is not formed like this. But it is kind of a sheep cloud. It is also known as a sheep cloud or a wool packed. Just like a wool kept side by side like this. Right? It looks like a woolly appearance you can say. That's why it is also known as sheep cloud or wool packed. They are wavy or parallel band. They are composed of supercool liquid droplets. Clear? Then comes altostratus. This is also a middle level cloud. They are either grayish or bluish cloud sheet. May cover all or large portion of the sky. Kindly look at the picture in front of you. This is nothing but the altostratus. I highly recommend you take this material, correlate with this, try to observe the sky, okay, and try to identify which cloud belongs to which class, okay. Low level cloud. Low level cloud, the first one is Nimbo-Stratus. Nimbo-Stratus is a gray cloud layer, often dark. It is a rain, snow or a sleet cloud. It is never accompanied by lightning, thunder or hail. strikes of rain or snow falling from this cloud do not reach the ground area. Okay, it is known as Virga. Clear? This we will continue tomorrow. Okay, low level clouds, because there are many other important points that we have to discuss regarding sleet, what is Virga, all of this, hail, storm, different types of precipitation, which we will continue tomorrow. We will end the session here today. We will continue tomorrow. Anyway, thank you so much for your patience and cooperations. We will meet again tomorrow at the same time. Okay. Bye.